Hi, welcome to the first video in my Algebraic Methods series. So to start off with, we're going to look at expansions. So we're going to look at how to expand brackets, and then we're going to move on to how to reverse it and factorize. That's our main goal. We want to be able to factorize. But why do we want to factorize so badly? And this is going to be the main focus of this video. So potentially you would have already seen how to solve things like quadratics. So with a quadratic, we get everything on one side. So say we have x squared plus 2x plus 1 equals 0. And then we factorize, giving us x plus 1 squared equals 0. And well, what can we do to both sides? We can square root both sides. And we can subtract 1, giving us our solution, our answer. We know when x squared plus 2x plus 1 is 0. Okay, you might not think that's very useful, but imagine that we have a function that is telling us certain things about an environment, and we want to know when does this environment hit a certain level. So we might be told about the temperature. Our function, it tells us the temperature. We want to know when does the temperature reach this amount, because bad things will happen at this amount. We can then solve that and find out the time. That's the whole point. Now, why do we want to factorize? Doesn't really illustrate in this example very well, but the reason we want to factorize is because once we factorize, we can reduce our equation into two simpler equations, or many more simpler equations. So suppose we can write an equation as f of x times g of x. So we've got two functions multiplied together equals 0. What we're going to be able to do is we're going to split this into f of x equals 0 and into g of x equals 0. And most of the time, these are going to be much simpler equations. But why can we do this? And this comes down to a very sort of fundamental idea with numbers. So let's state this here. If two numbers multiplied together equals 0, then one number must be 0. I should probably actually put here at least. So let's actually state this as an equation. What we're saying is, if we have a number a multiplied by a number b, and then a or b equals 0. So why does this help our equation? Well, if we have two functions multiplying together to equal 0, at any point, at any value of x, these are just numbers. So if I want this equation to be 0, then one of these functions must be 0. So if I want to find all of my solutions, I split it up into two equations. I find out when is f of x 0, when is g of x 0. And that is all of my possibilities because of this here. Because if one of them wasn't 0 and the other one also wasn't 0, then they can't possibly multiply to give 0. And let's have a look at a proof of this. So let's have a look at a proof. So what I'm going to do is I'm going to assume a and b do not equal 0. So an equal sign with a slash through just means they don't equal 0. We have that a times b equals 0. That was sort of our statement at the top. This is what we've assumed is true. Now, because a and b are not equal to 0, I can divide by them. So I could divide by a. So I can divide both sides by a. Previously, if a was 0, we wouldn't be able to divide by it. You can't divide by 0. So this gives us that b equals 0, because the a will cancel. I'm dividing by a, but I've already got a multiplication by a, so the a will cancel. That gives us b equals 0. But this is a contradiction. This breaks our assumption. So this is a contradiction. So a and b can't both be non-zero. So yeah, let's just have a look at an example where we've actually got some values of f(x). So let's say we have x squared plus x times x plus 1 equals 0. I can split this into two equations, x squared plus x equals 0 and x plus 1 equals 0. These two equations we're going to see how to solve later on. One on the right is quite easy, one on the left is quadratic. But yeah, hope this has been helpful, and I'll see you in the next video.